So 6.4 looks at kind of what we've been doing, but now we're talking about percents going up. There's a couple ways to do it. One is kind of a two-step way that they tend to teach kind of at the lower levels. And then one is more the way you're probably going to end up doing it as you do this later on in high school. I think you're going to like the second way. So that's why my notes have like the not as cool way. I'm being judgmental. And the way I like doing it. So ways to do it. I should back up. Percent increase is when something goes up by a certain percent. So when something goes up by a certain percent. So in other words, when I bought my Honda Civic, everybody saw, oh, Mr. Falk, he's really cool. He bought a Honda Civic. So the value of Honda Civics worldwide went up by 10%. And so that would be an example of percent increase. Okay, so the not as cool way to find it. One would be find the increase. So if the value of Honda Civics went up by 10%, we'll find out how much 10% is, and then add it to the original. Because if you know it went up by 10%, you find out what 10% is, and you just add it to the original amount. So I have an example there. You buy skis for $400. They add on 6% sales tax here in Michigan. So what's the total cost? So what you could do then is say, all right, well, my percent is going to be 6%. I put in as 0.06. The skis are $400. They're charging me $24 in tax. I can say, well, skis are $400. Add the tax to it. You get the total $424. Yes? Uh-huh. So you can do it. There's nothing wrong with it. It's just two steps. Find the change and then add it to the original amount. What I'm going to do is I'm going to try to do it all in one step. You could say because I'm lazy or because I'm resourceful, depending on if you like it or not. So in my little box here, I'm going to say, when doing percent increase problems, add 100% to the percent increase, comma, then do the problem. I'm running out of space. So then do problem. Kind of fit it in, almost, sort of. So, but if you just add 100% to it beforehand, you can do it all in one step. So we're up here, I went and found out what 6% of it was. Do you agree? If I buy skis and they're going to add 6% on, I still have to pay 100% of the cost of the skis plus 6% more. Yes? So what I mean by that is instead of doing 6% like I did here, I'm going to look at it as though I need 106% of that $400. How would we write 106% as a decimal? Go for it, Luke.
1.06.
Perfect. So when we did percent times the original equals the new, for that percent, I'm just going to put in 1.06. I'm going to multiply that by 400. That's my original cost. And in one step, I'm going to find out what's 106%. So it would give me $424 if I punch that into my calculator. Yes?
I get it.
So some people, I know the Learning Lab last year was teaching people this first way, and there's nothing wrong with this first way. If that works better in your brain, do it. But I think that you might want to just do it in one step. This is the way I'm going to. Can I do second way works for people? Can I do that in class and not be the hated teacher that's trying to teach at high school level? Okay. So boots. The boots you want cost $152 in the store. If the store had a 90% markup, what was the wholesale price? So, okay. So this might not make a ton of sense, but I used to work in a shoe store my senior year in college. It was sweet. I got all kinds of footwear for really cheap. But if we do percent times the original equals new, their markup actually was higher than 90%, but we'll just pretend it's 90%. So the boots you want cost $152 in the store. So that's going to be the retail price. That's going to go in here for the new. That they cost $152 after the store marked up the price 90%. So in other words, the original is going to be what we're trying to find. Maybe my story problem is just too confusing, but the store pays a certain amount of price to Vask or to Timberland or whoever makes the boots, And then they add 90% onto what they paid for it, and then they sell it to you for almost double the price. So if we have an increase of 90%, what do I put in right there for my percent? 90. Yep, I need to put in there a 190%. So I need 190%. 190% in the problem is going to be
1.9.
perfect. You move it 2 jumps, right? So 1.9 or 1.90, if that makes it easier to see what's going on. And now to solve this, I divide both sides by 1.9. Divide by 1.9. So my calculator, I type in 152 divided by 1.9. And I find that the boots that I'm paying $152 for only cost the store, any guesses? $80. So they're making $72 off the cost of the boots. It actually is 100% markup at the store I worked at. So it's double. They charge you double what they pay for them. Isn't that nuts? If you notice, what I'm probably doing in the notes is making that unknown be in a couple different places. First, the unknown was over here. The second one, my unknown was at the original. So this next one is probably going to be the unknown is at the percent, same as what we did earlier in the notes. So what is the percent increase when something is marked up from 135 to 75? So percent times the original equals the new. So something is marked up to 135 from 75. Where do I put my 135? That's my new, because it's marked up to that. From, so my original is 75. Should I put in the percent sign or an X? What's your preference? X it is. So to solve for X, we would both sides by 75. So divide by 75. If I punch in 135 divided by 75, I get a 1.8. Do we like that for an answer? Ooh. You guys are catching my tricks. What's the percent increase? So the final answer, the percent increase is going to be, oh, you almost caught my trick, 80%. For those that are getting there, do you agree this 1.8, that's the same as 180%? The 100% is just the original. The markup is 80%. So it's an 80% increase. Kind of like before, we had a, where was it? So before we had a 90% markup in the problem. So we made it 190% or 1.9. We need to do that backwards. Here we're at a 1.8 or a 1.80. It's 180%. But it's only an 80% increase because the 100% is just the original amount. We still good?